we were having across the river. He said, well, gee, you know, in my business, there's things that are so cut and dried. He mentioned the fact that Westerns all follow the same sort of plot. Couldn't we make a program, make a computer do something like that? It seemed to him it should be very simple. And so as we talked about it, it did seem that it could illustrate a number of points about artificial intelligence and this and that and the other thing. And lo and behold, I found myself talked into giving it a whirl. Of course, I would only do so knowing that we had as much capable machine as the TX-0 was at that point, and also Morse here was making that new macro system run rings around everything else. And so, believe it or not, I believe it took 6 calendar weeks from the time that we said yes, we would take a crack at it to where we delivered 50 scripts to New York City. And the way we designed that again, in order to get done at all in the time, it had to be a modular program, all these nice modern terms. We didn't call it that in those days. We just broke it up into pieces. And the central point, I think, was having two different memories, keeping track of where everything was, down to the individual actor's hands, and where they were in the room, and that sort of thing, so that then the logic part of the program, which again was the part that I wrote, could just have instructions that would say where things went. And then DIT made this very elaborate program that would compare the 2 different memory states before and after, and regardless of what it found, between those states, it would make a line of English script saying, put glass in left, take glass in right hand, put glass in left hand, take bottle in right hand, put the bottle back on the windowsill or the table or wherever you see. Very detailed. But it turned out that with this structure, no matter what went wrong, you got a good English script out. And that's in fact how they get the little debugging sequence, which was an actual error run from the program, where if you watch closely, the sheriff puts his gun in the robber's holster, and various strange things like that. But I should let Dip tell his side of the story. That's where the main structure of the thing came from.
Yeah, I've been asked whether that script was specially prepared, the one with the loop and the errors in it. It turns out the CBS people were there, and the printout started cycling, and they grabbed that sucker so fast.
Right off the machine.
That was the best thing they saw that day. That collection that Kobe wrote was 13,000 lines. We did it in 6 weeks. It was many layers of macros, and it was one of the first and only programs I've ever been involved in that had a real deadline. They were not going to postpone the shooting of this.
No way.
We had those scripts and that.
That's right.
What they got is what we did.
13,000 lines. That's really impressive.
Macro generated.
Macro generated, yeah.
But nonetheless, it was
modern high-level language. I mean, that's a 4th generation language.
That's right.
It was done in the 2nd generation.
Yeah. High productivity.
Yeah.
And a lot of fun.
What about some of the real workhorse programs that were done, some of the activities that were done in an electronic systems lab as a real user group? John Connolly, I thought, was going to be here doing the pulse height.
You mean Mark Connolly? Mark Connolly.
Mark isn't going to. Okay, Mark had a group, and that's where Did and I met, and we were part of that group trying to make pulsed analog, digital pulsed analog, because some of the operations in analog went fairly fast in those days, and so there was this belief that if you just mixed analog and digital together a little bit, you could get high speed. It turned out to be not true ultimately, but
it was true then.
Well, it was true then, and we had some very impressive performance.
That was work that Mark had actually started on Whirlwind. He had a rack of this pulsed analog equipment over there. It was things like multiplies and things like that went a lot faster in the analog world. As a matter of fact, this machine doesn't even have a multiply instruction, but they were doing flight simulation, and there, of course, the real time is the is of the essence. And there was a big argument in building flight simulators there whether computers would ever be fast enough to do exotic simulations in real time. You know, most of those things were done on pure analog machines at that time. So this was an attempt to bridge the two worlds, and he actually had successful equipment running. As I remember, there was being partly analog, there was always a lot of little tune-up and calibration problems, but I know he did some significant simulations on this machine. I think later that was moved perhaps to the PDP-1 also, because he was at that for quite a while.
Can you remember some of those? Some of the other that?
I remember all the time that we were working on it, there was a lot of working on a speech recognition synthesis.
Yeah, that was in the speed.
Well, of course.
And I recall someone...
But that was from the RLE group, not
That's
from our-
right.
Yeah.
from our-
Right.
I think they have other speakers for that.
Okay.
Yeah, but what else was done at ENSL? There was some radar simulation, wasn't it? Radar, because the ESL also had did a lot of radar work. Was phasing over. Did they use it?
There may have been one group did some work. I just remember.
One of the key things that actually with the program that Dit was working on, mostly when he was in my group, was again part of the computer-aided design project. We had started out working on the high-level language compiler development, and we developed the first of a series of languages that we went on to do. It was called the Bootstrap compiler, and it used, because we wanted to develop it simultaneously and in parallel for portability on both the TX-0 and I believe it was the IBM 704, may have been the 709, but I think it was 704 still. We started out with the language of this, the syntax of this language were the punctuation characters that you found on a key punch. Then we also had the alphabet and a few unused punctuation characters. And it was called the Bootstrap compiler because the compiler itself consisted of only 75 instructions on the TX-0 and about the same on the IBM machine. 75 instructions plus fewer than 300 words of storage of built-in tables which defined the language and also had space for the first symbol table. And the key item and why it got its name Bootstrap compiler was that I think it was the asterisk. If you terminated a program by an asterisk, the program was compiled and automatically hooked into the compiler in a standard way so that whatever followed the asterisk would be compiled by the modified compiler. And so in this way, you could bootstrap your way up into a very elaborate system. And fortunately, we had, I think, 4 symbols unused on this built-in symbol table, but you could write as the very first program ever compiled by this compiler was a thing that made a list-structured, sorted, multi-character symbol table so that then you could write big programs. And so we went on and bootstrapped this up, and Dit was the main both thinker and architect of this phase. And he had it with conditional macro expansion and free format input and output and the whole works. And we, in fact, used the Bootstrap compiler to write the complete first version of our AID compiler, AED, algorithmic, ALGOL extended for design, or ALGOL extended for, or what was it? Automated engineering design. That was what I knew I'd get it. But that was Dit's main tour de force. There was pulling all that stuff through the pipe.
So that was the beginning of
all the.
And a lot of the beginning of soft tech, as a matter of
fact. That's right.
Well,
that was the precursor of all the Pascals and Adas and so forth right up to today. 75 instructions was a pretty neat compiler.
That's right.
All in 4K.
Yeah. You remember any more about that?
The only thing I remember was a bit of joy I had writing a fully recursive macro definition and expansion capability in the language in less than 2 pages of code, 2 written pages of code that ran identically on the IBM 704, 709,
That's
and
right.
the TX-0.
Yes, we had the full portability between the machines all the way along until finally the limited memory on the TX-0, we had to leave it behind. But from the very beginning, we intended to have this full machine independence and stuck with it. It's fun. I think that's...
Okay, well, there'll be other chances.
Right.
When we turn the machine on.
Yep.
Okay. Good. Let's see. We're gonna play with the lights now for a while.
Yeah, I want to fix the lights here.
Okay. Let's see. I can get the next one. Huh? Yeah.
Plug them in. Hand me a P2 and do it. Ryan, give me that one. The one. Well, also, these lights are pointing over here. I'm not videotaping them.
Do you know how to put it in?
Balance. Push the button.
You have to twist and then push.
This is the console where the memories have on the boot box. Yeah, see the hose?
All of it?
Negative core memory. For its day.
Standing on small chairs is quick suicide.
Yeah. I don't have to touch this when I put it in.
What?
I don't have to release this to put it in, right?
Quite possibly.
That was just wrong. I never did that.
It still works, isn't it?
Oh, yes, I'm
Pointed that way towards the
Towards that chair? Right over the flexor writers?
Yeah, actually, we should move all the lights forward.
All the lights closer. Okay. Can you get the camera out of the way?
Everything over lights closer.
Uniform.
Yeah.
Don't worry about uniform, don't worry about uniform.
That's the old. That's the old one.
Well, we need something which is current.
Here it is. Here.
This one, okay, look at that.
This is yours. This is
Right.
And then what we'll do, I'll maybe use memory selectively and give you the display.
Well, for doing this, we don't need the memory.
Right. And I'll use,
You have to do the toggle switches for it?
yes, I'll use memory selectively for the temporary.
Yeah.
We'll have it available. And Doctor will work later on in the doctor.
The flexor writer works?
Yes, for Alan's program.
Yeah.
For Alan's program. Alan and Dave. I've done listening.
Hey,
on it.
my God, does this flip?
No, Doctor.
The flexor writer won't run for long. Its paper is off.
Well, we can work
Better
it.
than before. All right.
Way more paper.
I don't know how we're gonna do the screen.
No, I'm wondering what debugger is being
That's
used.
Doctor.
That's Doctor. Oh.
And we have Daly's cubic. I've run that.
Oh.
The paper stops there, but there's this
There's
much
more.
back here
There's
that
no
could be
more.
best.
I think we're ready. I'm ready.
Do you want Alan? Yeah, but they'll come in, why don't you guys start, and then one by one, Shag and Alan and Dave Gross will come as students. So we'll have two and one.
Then I'll drop out and...
No.
stay.
You and Jack stay, and then let's talk, and then we'll have students coming in. Jack, and probably this is the best time to give the overview, I think.
Well, as much overview as
Yeah, as you have.
as exists.
Right. Okay.
So I'm not.
Yeah.
Oh, hi, Gordon. It's a pleasure
Hello,
to
Jack.
be
Let's-
here.
Did you ever believe when this machine went down that it would ever come to life?
Do you know, I wasn't even present when it went down.
Unfortunately, we didn't have any real celebration.
Oh.
Because of the time lag, you recall it took 2 or 3 years to go through government red tape. The interest had died down and it just oozed out of the place, I would guess.
If you remember, in the fall of 1963, I became a member of Project Mac and moved my office over into Technology Square. And my connection with what was going on over in Research Laboratory Electronics kind of died away, starting about that time. I had much interest in the PDP-1, was interested in keeping that going. But when the news came that TX-0 would be shut down, I was so involved in other things that I was unable to pull myself together to get an appropriate ceremony. So that's disappointing.
When did the TX-0 actually shut down?
In 76.
76, yeah. Okay, so now I think the thing to do is, Jack, why don't you give a general overview of of the Dennis years of the TX-0's life when it was getting up and operational, and there was the large part of the research was cranking away on the machine. It was really in full use.
I'll tell you what the machine, how my relationship to the machine started. In 1958, I had just finished my doctoral thesis at MIT, and I had just been appointed instructor on the MIT faculty. And I moved into an office in Building 26, and at that time I soon discovered the existence of this marvelous machine down the hall. And having free time at that point and not having a research direction, I very naturally became a hacker on the TX-0. Now, I suppose people may have talked about this already, but when the TX-0 was brought to MIT, there was very little software with it. In fact, one major piece that came down from Lincoln Laboratory, or the two major pieces actually. One was UT3. Woodward's Utility Tape 3, it was called. And at least you could interrogate the contents of registers in the machine in octal and find out what the contents was if you understood octal notation. It did tell you what the instruction codes were, but of course that was rather easy since there were only 3. I mean, of course the operate commands had several possibilities which the UT3 understood, but it was a very primitive debugging facility. The other item which came to us from the Lincoln Laboratory was Munro Weinstein's tape, which was a primitive assembly program, at least primitive by our standards. But one must realize that Munro Weinstein had put this together without so much as the benefit of an assembler. The only tool that he had to put this program together with was UT3, as far as I know. Isn't that right, John? Yes. And so all we had was a binary tape of this and rather primitive assembler. Well, the first thing that I was inspired to do was to make improvements on the assembler. And in order to make progress in that, it called for finding out what was there. And therefore, I had to start out from a printout in octal of this assembly program and then sort of decompile the program into reasonable assembly language from that information. So that's really what got me interested and involved in the TX-0. Then, of course, more things attracted me. One was, of course, making improvements on UT3 itself. And at that time, my office at MIT was shared by Tom Stockham. Now, Tom Stockham, I don't suppose, has shown up here.
Don't
But,
know that.
no.
He's been notified.
But of course, Tom has gone on to get world renowned for his being one of the 8 panelists on the Nixon tapes. So, and also reconstituting Caruso separate from the orchestra. So he's quite notorious. But I spent a year or 2 with Tom Stockham, sharing an office with him in Building 26, and so we got together and had a joint project of making an improved debugging facility for the TX-0. And together we came up with the name FLIT. Now, I don't know whether anybody around here is old enough, well, I'm sure John is, to remember what FLIT actually is.
I wondered whether that is still sold or not.
I don't think so, because I mentioned this acronym for the debugging tape, and no one realizes where the acronym actually came from. But there was a commercial for this substance in which the character says, "Quick, Henry, the FLIT," because there's a fly buzzing around, and it's supposed to be, FLIT is very powerful insecticide for getting rid of bugs. But in our uses, it stood for Flexowriter Interrogation Tape. It used this machine to find out what was going on in the bowels of a program. So Flexowriter Interrogation Tape, or FLIT, was a program which allowed a user to talk in terms of symbols to the machine about the program. It would use the same symbols that were used in the assembly language. And I have no idea how unique it was at that time. We just thought it would be a good thing to do. It would be very helpful to users to be able to debug their programs using the same symbols that were used in the assembly language program. So we went ahead and did it. And that was that. Then I had heard from, there was some idea around, I think we heard about an assembly program that was developed at Bell Laboratories, which was a macro assembler. And that idea sort of intrigued me. I said, well, gee, if they can do something like that at Bell Telephone Laboratories, we can do it here. So I proceeded to work on taking the original assembly program and developing it into a macro assembler. And that took a fair amount of my time, kept me out of much mischief. And I don't remember when that program was first generally used.
It had to have been done during the first year, because I recall you did it while there was still only 4K memory, and everybody was quite impressed that you could do that much with the 4K. Wasn't that correct?
Gee, I just don't see how all of the stuff got done during that year. That's what I'm amazed by.
Wasn't it done before you picked up from Earl Pugh? And that was about the end of after about the first year.
Yeah, because after I picked it up from Earl Pugh, I was devoting my energies to improving the instruction code. I wasn't working on the macro assembler anymore, I guess, at that time. When did I take over from Earl Pugh? Do you remember?
Roughly after the end of the first year.
Was it only 1 year?
59. It was what, the
59.
summer of 59
I
or
believe
something
so.
like that.
Yes.
In that.
And we moved down the summer of 58.
Gee, I figured I was. When was the FLIT program first used?
I thought that was after there was 8K.
I don't think so.
No? Doctor came along after 8K with Alan Kotak.
Yeah, maybe FLIT was.
Maybe we should get Alan here to tell us.
Let's get Alan to straighten out
Because
history.
I had forgotten about Doctor.
Well, Doctor and Midas came together.
Those were
Yes.
much later, I think.
Yes,
Because
but they were during the 8K.
I programmed this 59, 60 era, and macro was there, and it must have been FLET was there,
Yes.
not DDT.
Yes.
And
Now, Midas was first done for the PDP-1, wasn't it? And then did a version get created for TX-0?
I'm not sure. Let's ask Alan.
Was yours?
Hi, Alan.
Here's Alan Kotak.
We got a weird problem.
What's the word problem?
Somebody is generating RF, maybe the machine, and just started about a minute ago, and it's coupling onto the camera. This happens at MIT every once in a while.
Let me,
Could it be
there could be the
generating
time
a-
pulses. Let me kill the time pulses.
It shouldn't, but it does.
Excuse me. I'll cut that.
Okay.
The time pulse, the only thing, well, unless it's power supply,
Unless the power is like.
there could be some power supply.
Those Burroughs boxes are really powerful.
Right. Wouldn't pass FCC
Yeah,
regulation.
that solved it. So this happened several times. I think you go to computer places.
No, it's still doing it, it's still doing it, it's still doing it, it's still doing it.
Well, then you drop back to where you were previously.
I don't know.
No, we can't repeat it.
Was the breakpoint feature having flip, was that unique at the time?
I have no idea.
Or had you picked
Well, no, that was, that was,
Was that available?
I think you said nothing new.
I don't remember.
thought that was pretty
Doesn't
unique.
serve very well either.
Well, I'm willing to believe that UT3 did not have breakpoint.
That's my recollection, but I'm questioning it rather than,
But I know we did something with a single breakpoint.
yes.
And then in in FLIT, we extended that to multiple
Yes.
breakpoints. One thing is that in order to make macro work, I was using so much memory for macro that I couldn't have a decent debugger in memory at the same time.
Right.
So I made macro
Microflit,
FLIT.
Yes,
right.
yes.
Now, did microflit get built before FLIT or after FLIT?
I think it was
It was after.
I thought it was after.
Yes.
Yeah.
It was after, and in fact, the conciseness of its output was picked up as being, in fact, an advantage by the user community. I guess, and then I guess it was Bob Wagner worked on adding symbols back in because you had stripped the symbol
Yeah.
stuff out in order to make it squeeze in.
Yeah.
And I think that that concise type of thing is what then carried forward into the DDT and programs of that sort.
This was not happening before you moved to whites.
That seems unlikely to be.
Yeah. Those are all incandescent
Right,
lights. They're not going to create RF interference.
Maybe one of the lights that you moved did something.
What about the monitor?
So you did doctor. What?
My memory is so poor.
I don't remember the
In
doctor
my-
program at all. I
In
forgot
my
all about
history, I
that.
say that you did. Now, I sort of, went through the notes.
I may well have.
When Sonus was doing Midas,
Right,
they were joint.
right. Well, I remember. I certainly did something.
When Midas went to the 6 symbols,
Oh yeah.
then you updated the utility, not updated, I mean, you rewrote
Right.
utility and it became doctor.
Yeah, well, I was certainly interested in that class of thing at the time because I also wrote the first GDP1 DDT program.
I've given you credit for that. And at the time,
I'm not going to
yeah,
deny
at the time, I'm pretty sure that I thought that
Okay, let's keep,
We're,
yeah, we'll keep,
we're going
Are we,
yeah.
We're getting good sound.
okay, fine.
Viewable
Maybe
video.
sound with stills.
Viewable video.
Yeah, so we gotten as far as some software which had been produced in connection with TX-0. Then, let's see, then we could talk about extending the order code, but
Well, there's the things that I think we might want to mention are the magnetic tape system. You have that in your notes?
oh, I have that down here as being, yeah.
I was the
Well,
original.
right, Gordon.
I started out as the designer of
Right, I remember
Yeah.
Jack.
That was when Gordon actually worked for me. I can't imagine that ever being the case.
That was, let's see, I was trying to think when the design was started. It was,
was about 62.
no,
No,
it
before
was
that.
Wasn't that?
61?
because I left.
Before you
You
went
see,
to
I mean,
Australia.
after all, the PDP-1 arrived in 1961, right?
Yes.
And
I was at DEC.
Right.
By that time, I was certainly totally concerned with developing the time-sharing system for the
Yeah.
PDP-1.
And I think that was that winter of '60 or something like spring. I think it was the spring of 1960.
Yes, that sounds.
And then in fact, that's how I learned about DEC, because I went out there to buy modules for the tape control unit, and then was doing that with
Well,
Jack.
that took us into big time computing.
Yes,
Right.
one tape unit.
One
anyway,
tape unit.
and big.
Oh yeah, I remember that my dream at that time, my schemes for storing everybody's images and files on this tape unit, so that they could be called up, and so that one user could take over the machine from another user. But that project was scuttled as soon as the PDP-1 idea arrived.
Yeah, the one arrived, and then we started that modification. You started interacting with DEC to build a time sharing system.
Yeah.
That's when time sharing was just.
Well, the interacting with that.
Computing today. So.
Well, I had some previous experience in this. I mean, the Whirlwind machine was not exactly formally run all of the time. My first large programming experience was developing, as a graduate student, a program to solve the transportation problem. Anyone? No,
Yes,
not
yes.
the transportation problem of Boston, but
Yes,
so
right.
the transportation
Right.
problem, which is a kind of economic model, linear programming problem. And I wrote a large program to do this Whirlwind. So I was, of course, led to go up to the Whirlwind computer at such hours as midnight or 1 o'clock or 2 in the morning to work on debugging, because then I could get my hands directly on the machine and play with magnetic tapes, look at the lights, get scope postmortems on my own, and so forth. So I was very familiar with this kind of informal way of working with the machine. But then that was formalized, informal. You didn't have an online debugging scheme. I had heard that various things that people like Doug Ross, who had closer connections to Whirlwind, actually had it in those days. You know, they could. I've heard that there was back rooms where certain privileged people could get at scope displays and neat goodies like that. But that was really behind.
Not for the run-of-the-mill user.
It's not for the ordinary user.
Alan, I think there's this. I think that very famous story about Minsky and McCarthy or Minsky and Shannon playing chess with the TX-0 and PDP-1, and I think you got to record that now.
Well, I was talking with Steve Levy a while ago, and it appears that everyone has his own favorite version of the story.
Good.
But my version is that after the PDP-1 had arrived, and before any formal...
Being an important story, could you move up a little?
Oh, sure.
So you get on camera.
Maybe if I could take this chair out of the way, it's, can we put it back? I hope this section can be edited out, maybe.
Yeah, the PDP-1 had arrived, and before any of the fancy high-speed parallel links had been installed between the machines, some of the hackers of the day and I were contemplating how we could make use of both computers, and we installed a single-bit serial line between the two machines. I forget what speed it ran at, but we cooked up our own sampling mechanism, and having gotten the line to work, we decided one thing we could do is just make a buffered typewriter program that you would type a line on one computer and would print on the other, and vice versa. Well, we got that working, and we said, well, what can we do with this? And I forget who, but someone suggested that what we should do is to emulate a chess playing program. since I and some others had been actually working on chess on the 7090 at the time, so we got together a panel of chess players, and they sat in the TX-0 room with a chessboard sitting next to the Flexowriter, and a couple others of us sat in the other room with the chessboard and waited till some appropriate people walked down the hall. And my recollection is, at least, that the first person I dealt with was some fairly gullible graduate student, and so we enticed him in. We said, "Oh, we have this great new PDP-1 chess program," and he said, "Oh, yes, and sit down here, play it." And so we would type the moves in, and the panel in the other room would make their replies, and we would move the pieces on the board. And this was going along pretty well for a while, but then there was some confusion as to one of the moves, and we got into an argument over the terminal, and the chess player started to smell a rat here. The last thing was I was typing in, "Quick, run out the door," you know. They were grabbing up their board and running out as he came through the connecting doorway. So that was one of the more amusing things. And I gather that other people used this to impress Minsky or Shannon or others, but that was kind of in the spirit of the day.
Let's see, Shag Gretz, Steve Roast, do you guys want to come in and talk about your experience on the machine now as students?
Take my lead.
Well, we stay around now.
Yeah, let's,
We need at least 10 minutes to change venue.
right, but we've got also, we want to get this section done, and then John Allen and Don Truxell are going to talk about the CIPG effort, and then we're going to turn the machine on.
Okay. Let's hurry up, because we'll never get to 3 o'clock.
We're going to make 3 o'clock, I tell you.
Okay, go.
We're right on schedule.
Oh, well, I remember how appreciative we were of the support we got from Research Laboratory of Electronics, and I think we should put that in.
And
The machine was really part of our...
department, Gordon Brown, for instance, the A to D,
Yes.
day track.
Yeah.
Yeah, Daytrack was
was about
EBSCO company, and
that was
Bernie
about-
Gordon, by the way, gave a talk at the museum about
I think that was
that, and
roughly-
Bernie was certainly
It
instrumental
was something
in
like a
analog-
10K output.
Yeah.
And Nuclear Science bought the dictate for you,
Yeah.
the Potter.
So, Shag, yeah, I guess, do you want to,
Sometimes I wonder what I'm doing here.
did you, well, did you program this machine or
I
not?
certainly did program this
Oh,
machine.
okay.
Well, then you belong here.
All right.
Close to the mic is the chair.
Okay.
Okay.
Well, my introduction to this, I had just been sort of eased out of the nest at Harvard, where I had learned about computers as a machine operator. And I learned how to write some programs in the 704 language. And my only knowledge of computers was the 704, which was about 3 times this amount of equipment. And ordinary programmers, of course, didn't approach it without an intermediary, that being the machine operator. You submitted your work and you got it back a while later. When I left Harvard and I came around looking for work, Jack Dennis, whom I had known when I was an undergraduate, needed somebody for the summer. I'm still not quite sure on what basis he hired me, but what he asked me to do was to write a diagnostic program for this tape unit that's over there behind Gordon's head. That's the Potter Type 3, I guess it is.
906 Mod 2.
906 Mod 2? Oh, that was Type Mod 3. Whatever it was, it's every bit the kludge that it appears to be from looking at all those fingers. And so I was set to a task that I had never done before, and I guess it must have come out all right. But here was, I guess everyone else has had the same impression. This machine was really, by 1961, quite a legend among programmers and computer people in general. And here, all of a sudden, I was going to be allowed to use it. And my first impression was, okay, who's the operator? And how do I submit my programs? And he just sat me down and said, this is it. What you see is what you get. So that was my introduction to this entire room full of machinery that was really under the control of whoever was signed up to use it at the time. I spent that summer writing the Diagnostic program. That was all of the money, I guess, was in his spare change drawer to keep me on. So that fall, I went to work for Doug Ross down in the Electronic Systems Lab. And it was through that following year, that academic year, from September of '61 to April or May of 1962, that first the PDP-1 arrived in the kludge room, right next to where the TX-0 was, and gradually I moved over to that, and out of that came Space War, which doesn't really have anything to do with the TX-0. But that's really about all I had to do with the machine.
What was the most interesting program that you worked for?
I guess it was really the Diagnostic. It was certainly the most extended one.
Yeah.
It was the first time I had to do anything with mechanical drives, where I had to worry about timing, about spacing over records. I didn't really do much else. I may have written a couple of utility programs, but beyond that, I really don't remember much.
Dave, do you want to talk about your experience on the TX-0? Here's Dave Gross.
Hi, Dave. Hi. Well, let's see.
Get as close to the console as you can.
I can talk today, Master. Yeah, I was a freshman at MIT in '57 when I came in. Building 26 was just being completed, and the 704 room was just being finished off. They gave glossy tours of that computer room. I was at MIT to learn about computers, but there was no computer science courses. I don't remember for any freshman option for programming until I think the very next year. So I guess it was about the '58 when my friends at the Model Railroad Club had discovered TX-0, and all the model railroaders became involved with the TX-0 and with other aspects of computers. I remember some personal experiences where I was told I was under no circumstances to turn this machine on because I was not an authorized user, and I was scared out of my wits to do anything to hurt this machine. It was well known to be a delicate thing. Let's see.
The DOTS program?
Yeah, the DOTS program, I guess, was the most elaborate program I wrote for this machine. It was a gameplay, or actually, it wasn't anything all that clever about the program. It did an exhaustive search. It was the game. It did a 3x3 matrix of dots. You connect the lines and make boxes, and the program could play it against the human. You selected your moves with the light pen, and one of the interesting options was that it could display the instantaneous state of the search on the screen by showing how the lines it was putting in and taking out as it went up and down the tree. Very interesting. And the other one useful thing I remember doing was actually working with Alan. We one night Alan and I decided it'd be awfully neat if you didn't have to run your programs through the paper tape reader twice to do an assembly. So we had the idea that we could run it through the tape reader, pass one, and write the program out on that mag tape, leaving enough space on the tape so that on pass two, the assembler could write the binary results back.
Right. No one, as far as I know, had ever actually managed to use the IBM type tape in a method whereby you would write and then leave room and then go back and write in between. It was always sort of you start at the beginning and you wrote until you got to the end. and it took some amount of effort, as I recall, to get that all to work.
We had to tune it to leave just the right amount of space, so that there's guaranteed enough space. But that actually proved to be quite useful because
Well, we also divided the tape into two pieces. We had two load markers. Every time we got a new reel of tape, we had to figure out how to put the two load points on the tape. And one was protected, where all of the main utility programs lived, the first piece, and then the second piece was available for user use. And you would rewind the tape, and then to get back to the second beginning, I remember we had these switches.
Hit it
here.
again. What am I supposed to do? Hit it again.
Right.
I have in my notes that your call tape was only 4 instructions long.
Right. We had this very short little tape, which I remember we punched it. We had this small supply of Mylar tape, tapes that we had to use over and over again. And you generally just pulled it back by grabbing the end in the reader. But anything to avoid punching binary tapes from this machine here, which I think punches at 17 characters or 14.
I think it's 10.
10 characters a second.
10 or 12.
Some really slow thing. So.
Yeah, that was really great. And you remember the expensive tape recorder program? Your FM. You had your FM
yes.
receiver here in the computer room.
Oh yes,
and
yes.
You
yes,
decided we'll hook it up. We'll hook up the audio to the A to D, and we'll write a program that will record from the A to D on that tape,
Right.
and then
That was digital recording 20 years ahead of its time.
We did it. Well, you and I, we bombed this program so it looked like an oscilloscope on the screen here, which was simultaneously with recording. And we'd write the whole tape as one long record. And then on playback, you couldn't do load from the live register back to the accumulator because that would create a whistle, because it did it, the partial had to carry 2 steps. We did an XOR, I think it was, into the accumulator, so it wouldn't make a whistle. And we played back, we used the Scopes D to A converter fed back into the speaker that was under the console. You could actually get reasonable.
I mean, you could recognize that it was Beethoven?
Yes, you could recognize the instruments. It wasn't bad, really, considering
digital recording.
Yeah, it worked.
How much was invested in the machine? That's a number that I'm sure we all want to read.
Dollar-wise.
Dollar-wise.
John had some figures on that earlier.
I can't figure that off the top.
Was it $2 or $3 million for the project?
Oh, the original.
Oh, yeah.
When we tried to move it to DEC, the contract officer at MIT said, well, this is still government property, and he had a price on it. It was $3 million. Then there were some digits that I don't know. The last 2 digits were $21. So they moved it down to the price of $1, something like $3 million, for development costs as it was carried on the books.
Okay, so the machine to develop was $3 million to develop a large core memory and the transistor circuitry, really, which was the beginning of the circuitry for the TX-2 and for the circuitry for digital equipment, to start Digital Equipment Corporation. So, in fact, it was a bargain for even today. Now I think we have one last user group, and then we want to talk about the final move with Stan Schultz. But let's have John Allen and Don Truxell now, both of who are now professors at MIT, and they were graduate students there and worked with the CIPG group, which was this picture group. What
Cognitive Information Processing Group.
Yeah.
Is its name.
Okay.
Is its name.
Is its name.
Right. Still is.
So let's get it.
You want to start, Don? Don actually precedes my involvement, so it's probably a good idea for you to start, Don.
I showed up at this machine very soon after becoming a graduate student at MIT because I had a lot of numbers to reduce from some statistical experiments, and it was the best desk calculator that we had around, which is in fact how we used it. But then people in our group started using it for its interactive facilities, primarily the display and also the speaker. Oh yes, many a program has been entered by the toggle switches. Hopefully we'll see some of those a little later. But we had under CIPG, which was headed by the late Sam Mason, a number of different things relating to people's interaction, displays of on the scope in order to measure reading speeds. We had a graduate student who was very interested in the subject since he was blind and couldn't read in the normal manner. He was interested in working on speech output and trying to compress spelled recordings of letters in order to speed things up. And that was about the time you got in, John, working on how to synthesize speech as an improvement on patching characters together.
It's interesting that the first synthesis by rule scheme that had been introduced in England by Holmes, Mattingly, and Sherm was implemented first at MIT on the TX-0, and we made heavy use of this wonderful bank of switches here to control the various parameters of that synthesis. And it was exceedingly effective. Certainly the TX-0 didn't provide real-time performance, but it was a very useful capability to have.
I remember when Francis Lee called me over to play that thing, I was half expecting it to come out with a Chinese accent. Instead, it came out with an English accent, because that's where we stole the tables.
That's right. Also, we did a number of experiments on pitch variations in speech synthesis, and I can remember doing those with the switch panel here very effectively. It was a very nice way to interact. Also, the speech synthesis work was part of the overall project within the group of building a reading machine for the blind. And I believe that the combination of the PDP-1 and the TX-0, I know, I shouldn't say I believe, that they were used together to provide the overall capability. That is to say, the character recognition part that Don was involved in ran on the PDP-1, and the speech synthesis part ran on the TX-0. And this connection between the two machines, which was somewhat tenuous, I might point out, was occasionally lashed together for a long enough period of time so we could actually read characters and produce output speech from the TX-0. And that was quite an undertaking. That was quite a tour de force of the capability of these two machines.
Yeah, we didn't realize that that was one of the early applications of multiple processors to the same problem. But,
that's right.
They were the only two that were available to us.
Yeah.
So that was the reason for using that. Actually, the scanner was located over in Building 20, communicating over to and under the control of the PDP-1, and then the recognized character string was transmitted to the TX-0, which then produced
the synthetic speech.
The synthetic speech output.
That was quite a lash-up.
Well, and it worked occasionally, and
that's right.
We had that. It was really a marvelous opportunity, as has been mentioned before, to be your own computer operator, and as somebody said, was sort of a mark of being in the in-group when John Mackenzie let you turn the machine on. Well, I can remember being at home, getting a call one Saturday afternoon from a professor, I guess I shouldn't mention his name. He said, I turned the machine on and it doesn't work. And I said, but you weren't supposed to turn the machine on. I said, tell you what you do, Mike. So you go sit in front of the console and put your hands on the typewriter. Don't move till I get there. And then I drove in and came in, and fortunately, he hadn't done anything terribly bad, but hadn't started up the clock sequence, because he didn't realize that little bit of lore, I guess.
Yes, actually, with the improper clocks, you could cause damage.
You could ruin the core memory.
Right. Ruin the core memory.
That's right. That's why I wanted him to sit here until I got there.
Yes.
There was another interesting thing that went on. Some of these things, of course, that we've mentioned are signal processing oriented, and I think Jack Dennis alluded to sharing his office with Tom Stockham, and it was on this machine that the first fast convolution algorithm by Tom Stockham was implemented, which consisted of taking the fast Fourier transform of each of the two signals, then multiplying them together in the frequency domain, and then taking the inverse FFT. And that work was first done here on the TX-0 when Tom was involved. It's another interesting application.
Great. Let's see, I think the thing to do is then we'll move on and look at the film we're going to go over, and Jack's
Right.
going to say some words to everybody, and then we'll come back and start the machine up. Is that the way?
That's good enough.
We were just about out
So we'll
of tape.
change tapes, and we'll
Okay.
move the audio a little bit left.
Okay. So we're going to be back here once again, but
I'm gonna move the camera over there so I can see, just actually see.
are we going to do anything